better. We'll find out shortly, I suppose. Let's see. Okay, are we back? Are we like actually live? Let's see. I think we are. Sorry about that. I think this should work now, but if not, I'm sorry. I don't know why MediaCom's being stupid today. So we'll go from here. So that's the mechanism for an E1 reaction. So we will make our carbocation, maybe rearrange it as necessary, and then we'll eliminate our product to make our product. Overall, these reactions are not very useful. The unimolecular ones here, because these are competing processes. We often have the same reagents and the same substrates with them, and it's kind of really tough to make the decision as to which one's going to happen. And so oftentimes you get all of them happening, and it's unfortunately that's the case. So no way to get around that. So these ones are kind of not as useful, but we'll see that they are important for us to study, because these are some of the ways, the only ways we can get certain products out. For example, we can't use a tertiary substrate to do an SN2 reaction. It's not going to happen, right? It's too sterically hindered for our nucleophile to come in and attack. But if we have an SN1 reaction, we will have our leaving group leave. We now have an sp2 hybridized carbon there, which is planar, which therefore allows us to attack from either side. Speaking of which, I don't think I actually did stereochemistry one on this. Okay. Excuse me. If we take a look at the same reaction, and we kind of did an SN1 on it instead of an E1, so just put some water, we're going to have two options that come out. I'm going to go ahead and put our carbocation there. I put it in the tertiary spot already, but we're going to see here. So remember that sp2 carbons like this it's planar, completely flat. So our nucleophile can actually come in from either side. It can attack from above or below. Meaning that we get a mixture of things. This is okay. Here, I'm gonna make this a little bit better so that we actually. Oh no, I can't make it an ethyl group either. What can I do on this? Let's make it isopropyl. Why not? I just want some stereochemistry on this. So, it can attack from either side. So just making this a little bit more, so we can actually be chiral. But we see here we get the enantiomer as well. It can attack from above, giving us the OH on a wedge, or it can attack from below, giving us the OH on a dash. And we're going to see that we're going to end up with both, right? So as a result, we often will describe the product of this reaction like this. Oops. we'll put a plus minus next to it. And it doesn't really matter which one I put on a dash. Put that one on the dash, sure. Our OH group would be, we would say plus minus, which means it's racemic. So we'll end up with a racemic mixture using SN1 reactions. E2 or SN2 reactions always give us inverted stereochemistry. If you started with R, we'll probably get S, depending on our nucleophile. And so we get the inversion of stereochemistry. We only get one enantiomer, though. With SN1 reactions, we end up with both enantiomers. And that's because of this planar carbocation. We can have it attack from above or from below. Does not matter. 50-50 chance for either one. And so we get a 50-50 bit of products out. And we'll describe this as racemic by putting a plus minus in parentheses. All right. I could have put the OH on a dash, drawn the other enantiomer plus minus. That's the same thing. Doesn't matter. But we will end up having both enantiomers here. Okay, so where shall we go from here? So we've put all four of our mechanisms forward, and kind of in the end of this chapter, there's a nice little chart that I'm going to share with you before we talk more about some of these. Aha! So, I have the book. I'm going to show us when to kind of predict what's going to happen. And it's a pretty interesting thing here. So, here we go. We're going to have our substrate. Just for those of you who don't have the book. And then we're going to have our reactants up here. So if our reactant is a strong base that is a weak nucleophile, if we have a strong base that is a strong nucleophile,